Object-oriented programming in Python, access modifiers. Object-oriented programming languages such as C++, Java, etc. controls the access to class resources like attributes and methods using the keywords like public, private, and protected. These keywords determine the accessibility of the class resources from outside the class. In Python, there are no such keywords for controlling the accessibility of the resources. In Python, accessibility of all the resources of a class are public by default. That is, all the resources are accessible from outside the class. Let's understand this with an example. Let's first define a class person without using any access modifiers. Let's initialize the attributes with the supplied arguments. Here the data attributes are name and ID_number. We will also define a function, show, for displaying the attributes of the objects. Here the print function prints a f-string or a formatted string with the attributes of an object. So, we have defined our class, person, with two attributes, name and ID_number, and one method, show. Now let's create an object of the class, person. The variable Lisa point to the object. The object Lisa has two attributes, name and ID_number. For this object Lisa, the name is Lisa and ID_number is 123. Here is a graphical representation of the object. Her name is Lisa and her ID number is 123. So, this is our object, Lisa. Now let's try to access the object's attributes from outside the class. The print statement here tries to print the attribute, name. Let's run the code and see what happens. As you can see, we are able to access the attribute's ID_number without any issue. This is because the ID_number attribute is public by default. That is, it has no restriction from accessing it from outside of the class. Now let's try to display the name attribute. And, here too, we are able to access it from outside of the class. This is because, here name is also public. Now let's call the show method. As you can see, this is also accessible. This is because, the method, show, is also public. That is, in class, person, all the attributes including a method are public. Now let's check whether we are able to change the attributes from outside of the class or not. The object Lisa was created with these attributes. Now let's change the attributes as shown here. Now let's run the codes. Yes, we are able to change the attributes from outside of class. Now we know how public attributes behave. Next, we will learn how to make the attributes private. Let's copy this class and paste into a new file, private.py. Creating the same object, Lisa here again. As all the attributes of the class, person, are public, we can access the attributes from outside of the class. Now let's make the attribute, ID_number private by prefixing it with double underscores. Let's change the attribute names in these places. As we can see, the attribute ID_number is no more accessible from outside of the class, and the interpreter is throwing an attribute error. This is because we have made the attribute ID_number private by prefixing it with double underscores. The attribute name is public, so we can access it easily from here. Now let's access the show method. And yes, it is accessible. Now prefix the method with double underscores and try to access it again. See, we are unable to access the method show. This is because we have made it private. So, in this part we have learned how to make an attribute private by prefixing it with double underscores. Now let's move to the next part of protected attributes. Let's copy this part of the code and paste in a new file, protected.py. Now let's modify the code with protected attributes. Protected member names are prefixed with a single underscore. So, in our code, _ID_number and _show are protected members of the class person. Let's create an object Lisa of the class person. Let's run the code and check the result. Although _ID_number is a protected member of the class, it is still accessible from outside the class. In Python, protected members are just a kind of convention. It instructs the programmers not to access these members from outside the class. The interpreter does not restrict access from outside of the class. Now let's change the attribute _ID_number. As we can see, we are even able to change the value of protected members. So far we have learned the behaviors of the public, protected and private members of a class. Now we will see the accessibility of such attributes during inheritance. Let's consider this example. Here we have defined a class person with public, protected and private attributes. Here name is public, sex is protected and ID_number is private. And the methods, show is public, _show_ID is protected and __show_ID is private. Then we have created another class student that inherits the person class. So, here person is the parent class and student is the child class. The child class has an additional attribute, DOB for date of birth. Here the class constructor init initializes both of the parent and child classes. The super function is used for initializing the parent class. First of all, let's create an object of class student. Here, Sam is an object with the attributes, name, Sam, sex, male, ID_number, 123 and DOB, January 5, 2002. Now let's try to access the attributes one by one and see what happens. Name is accessible as it is public and inherited to the student class. Now let's access _sex, and yes, it is also accessible as it is protected. Protected members are inheritable. Now let's access double_ID_number. The interpreter throws an attribute error. That is, this member is not inherited to the student class. Now let's try to access the methods one by one. Public method show is accessible. Protected method _show_ID is also accessible. Private method double_set_ID is inaccessible. This is all for today's lesson. Please note that Python's access modifiers are not very strong. One can easily breach these restrictions by other means that will be discussed in our next lesson. Thanks for watching. Please like, comment, share and subscribe the channel for more such useful lessons. Happy coding, bye!